Alright, in this lesson we'll look at 3D vectors. Do all the same steps as you do with two-dimensional vectors, and we'll just talk about more addition and subtraction, scalar multiplication, and then we'll talk about magnitude and unit vectors. Alright, so there's the third component, that's vertical, and on the IB test you don't have to be able to graph these, but just to show you what they mean and how they're graphed. This is the x-axis, the y-axis, and then z is vertical, and so we can graph these by just making a rectangular prism. So we're going to go in the x direction 1 unit, -2 in the y, and then up 1. So x direction is positive this way, y is negative this way, so that takes us out there. So we have to make that parallelogram, and then we'll move up this distance, but it's only going to be right here, and then that distance will be right there. So if we draw something like this, so we have that prism, and then the point is right there. The point is right there. This doesn't represent the point, it represents the vector, so then we would draw the vector pointing to the point, and that's how we visualize three-dimensional vectors. And here we just have some easy arithmetic. So 2a minus b, 2, I think it's helpful just to write column vectors. So we'll have 1, -2, 1 for a, 3, 5, -2, and multiply times everything. 2, -4, 2, 3, 5, -2, and 2 minus 3, -4 minus 5, and 2 plus 2. Alright, pause the video and try the other one. Three, 5, -3, 1, -2, 1. 1, -2, 1, and then b is 3, 5, -2, multiplied by 3, 3, -6, 3, and we'll get 6, 10, -4, and we have 9, 4, -1. why don't we just do one here, one problem. Here it's just, we have a little new vocabulary, and we talk about position vectors. So position vectors always start from the origin. Often they're, well, you can label them as OA, but you can also just name this vector A and this vector B. So we're going to just do this scalar multiplication like we just did in the previous example, and then add. So pause the video and try that one. OA, OB, OA, and OB. So multiply everything, we get negative 10, 15, negative 5, 6, 2, 4, negative 4, 17, negative 1. Okay, the magnitude. We just, for a two-dimensional vector, the magnitude is just going to be the Pythagorean theorem. We square each of these, add them, and square root. And then for in 3 dimensions is a little less familiar, but we still do the same thing. We can square all 3 of them, add them, and square root. So the notation is for magnitude is the absolute value symbol. That'll give us magnitude, and so this is going to be 1, the coefficient of I, the unit vector I, is 1. So we'll have 1 squared plus 3 squared minus plus negative 2 squared, square root 1 plus 9 plus 4, square root 14. So the magnitude of the vector is radical 14, and that's also saying it's the length of the vector. And just like we saw in the beginning, it's just some vector in space, and we find the length of that vector. And pause the video and try B and C. So we'd write the column vector with the magnitude symbol. This is equal to this, and then we have 1 plus 9 plus 49, and that is square root 59. Part C, 3i plus 2j, 3 squared plus 2 squared, 9 plus 4, 13. And with the magnitude, then we can find unit vectors. So a unit vector, unit means 1. So it's a vector with a magnitude of 1, a length of 1. And we can create that by dividing this vector by its magnitude, and then it will have a magnitude of 1. So if we, in 2 dimensions, it's easy to look at the graph. We have over 1 up 2, and that vector has a magnitude greater than 1. Well, we want to shorten it down to having a magnitude of 1, so we'll just divide it by its own magnitude. So the unit vector is going to be the vector divided by its magnitude. So that's 1 squared plus 2 squared, square root. 1 plus 4, we have radical 5. And we'll just divide each of these components by radical 5. 1 over radical 5, 2 over radical 5. And then we can rationalize by multiplying by radical 5. And here we have 2 radical 5 over 5. Okay, and it works the same way with 3-dimensional vectors. So pause the video and try B. The unit vector is equal to the vector divided by its magnitude. One plus 9 plus 49. And that'll be 59, radical 59, 1 over radical 59, 3 over radical 59, 7 over radical 59. So that's the unit vector. Its magnitude is 1. And we can rationalize radical 59 over 59. 3 radical 59 over 59, 7 radical 59 over 59. All right, and then what do we need unit vectors for? Well, they help us find velocity vectors, because if we have the unit vector, we know the direction, and then we just have to multiply it by speed and we'll have a velocity vector. Alright, so we have a vector that gives us a direction, and then we need to have it have a length or a magnitude of 5. So we just have to find the unit vector and then multiply it by 5. That'll give us a velocity vector. So we could just say that the velocity vector is the speed times the unit vector, which is the vector divided by its magnitude. So we have 1, 1, negative 1, and then this is going to be 1 squared plus 1 squared plus negative 1 squared. That'll be 3, square root 3. And then we'll just multiply everything. Why don't we put 5 over radical 3 times the vector. We can just take care of the rationalizing here. And when you look at a fraction and a vector, make sure you're not thinking about multiplying the numerator and the denominator. There are no numerators and denominators here. They're all separate. This fraction has to multiply by each of them. Okay, and one more question. So here we just have to be careful. This could be an IB test question. They just kind of twist around the question to see if you really know what's going on. If they have equal magnitude, well, we could make an equation with the magnitude formulas. There's an x involved, but when you see the 3 and the 4, be careful that there's a k over here. So really, this is 3, 4, and 0, and this is going to be x, 0, and 3. So if we have 3, 4, 0, the magnitude of that is equal to x, 0, 3. Then we can just square everything. Square root. So we'll have 9 plus 16, radical 25, x squared plus 9. Why don't we just square it there? And we'll have a 25, x squared plus 9. Subtract 9. And square root. All right. So x could be positive or negative, and that seems reasonable. You could just have it going in either direction, in either x direction with the same magnitude. Okay, stop there.